Today we'll do physics second chapter, work, energy and power. First we'll start with work, and I believe everyone is familiar with the word work. Okay, in our common language, the work is a sort of exertion, either it is physical or mental, like writing, playing, cooking, going to the office, going to the school, running, walking. All these activities are considered as work. But in physics, the work has different definition. So how do we define the work in physics? Work is said to be done when the force is applied on a body, when force is applied on a body and the body moves or displaces, then we say that work is done. So that means, how do we define the work? When the force is applied on a body and the body displaces towards the direction of the force, then we can say that work is said to be done. Let's take some example. Book is lying on the table and you push the book and the book moves from that position, for position, initial position. So that means the book displaces, then we say that work is done. Okay, or you pull a chair in order to sit. You are pulling a chair means you are shifting the chair from its initial position. That means you are moving the chair or displacing the chair. That means work is done. Okay, so from the physics we can say that work is said to be done only when the force is applied on a body and the body displaces towards the direction of the force, right? So let's say if you stand in front of the wall and you try to push the wall, you spend lot of energy, you spend lot of time and you start sweating, right? You got tired, but the wall did not move. At that time, the work done is zero. That means we did not do any work because the wall did not move at all. So here, that means work is said to be done only when the force is applied on a body and the body displaces. Okay, so how we like write work done? Okay, formula work done is written as force into displacement in the direction of the force. Okay, so then what are the units for the work? So that means, or other way we can write simply, work is equals to force into displacement. Sorry, displacement is written as S. So if you want to know the SI unit of force is your Newton and the displacement is your meter. So therefore SI unit of work done is Newton meter, or simply we say that Newton meter is your Joule. Joule, or you write as Joule, J. Okay, and CGS unit, if you see this, work is equals to force into displacement. In CGS unit of force is your Dyne and the displacement is your centimeter. So that means therefore CGS unit of work done is your Dyne centimeter, or we call Erg. Okay, so these are the SI unit. SI unit is your Joule, unit of work is Joule, and CGS unit of work is your Erg. In the Icse often comes to find the relation between the Joule and the Erg, or to find the relation between the SI unit of work and the CGS unit of work. So how do you derive the relation? Okay, let's see relation between Joule and Erg, or the relation between the SI unit of work and the CGS unit of work. Okay, so that means here we know 1 joule is equals to here Newton, 1 Newton into 1 meter. Okay, so that means 1 Newton is how much here? 1 Newton is 10 to the power 5 Dyne, and into, that means it has to convert into centimeter because all is here Dyne centimeter. So 1 meter is equals to 10 to the power 2 centimeter. This is equals to 10 to the power 5. When the like terms are multiplied, powers are added. 5 plus 2 is here 7 Dyne centimeter, and Dyne centimeter is here Erg, is here 10 to the power 7 Erg. So this is how we derive the relation between. Just you have to know that 1 Newton is equals to 10 to the power 5 Dyne. Okay, clear? This is how we derive the relation. The relation between the joule and the erg is here 1 joule is equals to 10 to the power 7 erg. Okay, this is the relation between the joule and the erg. So that means sometimes in the ICC it will also ask find the relation between the SI unit of work and the CGS unit of work, and you have to do the same way. First, only there you have to write first SI unit of work is your joule and the CGS unit of work is your erg. Then we know 1 joule is equals to, and we have to proceed the same way. Clear? Let's take one example. If we have a body mass m and we are applying 10 Newton force on the body, and the body is displaces by how much? It say that 10 meter. And the question is find the work done. We know that work done is equals to force into displacement. Here force is this much and displacement is here. So force is here 10 Newton and the displacement is 10 meter is equals to 100 Newton meter is the work done, or simply we can write 100 joule. So your work done is your 100 joule. This is how we find the work done. Okay. So also we have written that 1 joule is equals to 1 Newton into 1 meter. Okay. So from here we are writing 1 joule is equals to 1 Newton into 1 meter, or 1 erg is equals to 1 Dyne into 1 centimeter. So that means if the question will come, what is 1 joule of work? Okay, so 1 joule of work is said to be done when the force is applied, 1 Newton force is applied on a body. Say that if the body is here and if you apply a force of 1 Newton and the body is displaces by 1 meter. Here the 1 Newton force is applied here and the body displaces by 1 meter. So then we can say that the 1 joule of work is done. Then we can say that 1 joule of work is said to be done. So how do we define the 1 joule of work? 1 joule of work is said to be done when 1 Newton force is applied on a body and the body displaces by 1 meter in the direction of the force. That is called 1 joule of force. Similarly, we can define 1 erg. If we have a body and we apply a force of 1 Dyne and the body displaces by 1 centimeter, okay, then we can say that 1 erg of work is said to be done. Okay, so how do you define the 1 erg? 1 erg of work is said to be done when the force of 1 Dyne is applied on a body and the body displaces by 1 centimeter. Okay, so this is how we can define. It's very simple. Just we have to know the formula. 1 joule is equals to, how do we define? 1 joule is equals to Newton meter. Joule is equals to Newton meter. So that means what is 1 joule of work? 1 joule of work is said to be done when the force of, when 1 Newton force is applied on a body and the body displaces by 1 meter, then 1 joule of work is said to be done. Clear? And these definitions are very important, you need to know. Okay, is equals to force into displacement, and the displacement will be towards the direction of the force. So we say that when the work done is 0 here, okay, so that means when the force is 0, when force is 0, the work done will be 0, because work is equals to force into displacement. If the force is 0, when force is 0 into displacement, this will become 0. And similarly, when displacement is 0, your work done will be force into displacement, force into 0, this will become 0. Clear? So we can say that work depends upon the two factors, one is the force and other is the displacement. It is not necessary that when the force is applied on a body, the body displaces along the direction of the force. There are some cases when the force is applied on a body, the body displaces but not along the direction of the force. Amount of work can be calculated two ways. One is first one is by finding the component of displacement along the force, and other is by finding the component of force along the displacement. First one we'll do by finding the component of displacement along the force. If you apply a force here, constant force along the direction AB, the body will move from A to C. So that means its displacement will be, displacement S will be along A to C, which makes the angle theta with the direction of the force. Okay, and here displacement will be a AC is your displacement is. Okay, so now if you have to find the component of displacement along the direction of the force, we have to make CB perpendicular to AB. Okay, if you make CB perpendicular to AB, then the component of displacement along the force will be AB. This will be the component of displacement. So we know that work is equals to force into displacement. This is equals to force into AB, component of displacement, component of displacement, AB. So here in triangle ABC, so cos theta is equals to, first we have to know that some people have curly brown hair turns permanently black. In trigonometry we have drawn here this. Okay, so here curly brown hair. So from here we know that cos theta is equals based upon hypotenuse. Only this is, we can do this when there is a right angle triangle. So the base will be at AB here, base upon hypotenuse, which is equals to, base is here AB, and the hypotenuse side which is facing the right angle, this is the side AC is facing the right angle, or we write cos theta is equals to AB, we don't have the value, and AC is how much? We already got AC is the displacement S, or S cos theta is equals to AB. We got AB, the value of AB, then we can write therefore work done will be your force into displacement AB. AB is your S cos theta. So that means we can write here expression to find the amount of work when the force is not in the displacement is not along the direction of the force. That time we find component of displacement, that is work done is equals to force into component of displacement along the force. Similar way we can do the second one here by finding component of force along the displacement. Okay, so suppose we apply a constant force here, okay, and force here on the body. Again the body displaces towards the C, A to C. Here displacement is again S only, A to C only, but suppose if you have to find the component of force here, suppose if we take P here, P and the A is the magnitude and the direction of the force. Okay, so then the component of force along the displacement will be here. The force will be acting this direction here. Okay, then from P, if we draw a PN perpendicular to AN or NA, then NA will be the force, okay, component of force along the displacement. Okay, so here we'll make the theta here now. Okay, so here work is equal to force into displacement. Here this is component of force along the displacement will be NA. This will be a NA into S. Correct? Then in triangle again PNA cos theta is equals to base by hypotenuse. Okay, base is here, AN is the base or NA is the base, and the hypotenuse side facing the right angle is here PA is the hypotenuse here. PA is here hypotenuse, or cos theta is equals to P is how much? P is the force, NA upon F, or this will become F cos theta is equals to NA, right? Therefore work done is equals to force. Okay, so force is what? NA. NA is what? Force into cos theta into displacement, and this is the amount of work. This is how we'll find the component of force along the displacement. That is, work done is equals to component of force along the displacement into displacement. These are the two ways we can find the amount of work when the displacement of the body is not along the direction of the force. Now we have the new formula for the work. Work is equals to force into displacement into cos theta, where theta is the angle between force and displacement. Then we can say that work now depends upon the three factors. One is your force, another is your displacement, and other is the angle between the force and the displacement.